Hello students, welcome to my YouTube channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of series on online electronics laboratory, and in this part we will discuss lab exercises on transistors. The assignments here includes the common base transistor, common emitter transistor, JFET and MOSFET characteristics. This is the third assignment, that is JFET transistor characteristics. In junction field effect transistor, this is the configuration which we have used for the experiment. We have to connect the circuit as shown here. Again we will use two DC supplies, one between gate and source terminal and another supply between drain and source terminal. We will observe the output voltage and output current. First of all, we will keep VGS 0 and we will vary the DC voltage at the output side and we will observe the current and voltage at the output side. Then we will keep this VDS constant and we will vary the DC voltage at the gate side and we will observe the drain current for different values of VGS. Let us see how JFET works. It is an N-channel JFET, as you can see arrow on the gate lead. We have simply connected the supply voltage to drain terminal as well as the gate terminal, and we will observe the drain current with respect to gate voltage and the drain voltage. This is the drain voltage and this is the gate voltage. Initially gate voltage is fixed to 0 volts. The ammeter shows the drain current and the voltmeter here will show the drain voltage. So we have fixed gate voltage to 0 and we are increasing the drain voltage and the drain current is increasing. We have kept the drain voltage as 2 volts. The current is reached to maximum value, that is 10 milliamps, as it is set in the milliamps range. Till now the gate voltage was 0. Now we will increase the gate voltage with the drain voltage fixed to 2.4 volts and we will observe here the drain current. As we are increasing the gate voltage, the drain current is reducing. The drain voltage is fixed to 2.4, as you can observe on the voltmeter also, and drain current is decreasing slowly as we are incrementing the gate voltage. Now we have fixed it. Observe the gate voltage 1.7 and we are now incrementing the drain voltage. When you increment the drain voltage, this shows the pinch off, right? Incrementing the drain to source voltage is incrementing the current. Current has reached to 2 milliamps value. Now if I go on increasing the VDS, there is no change in the drain current. That is, the drain current has reached its maximum value. The pinch off has occurred in the channel that we are observing in this practical. In this experiment, when we kept VGS equals to 0, the drain current was increasing as VDS was incremented and it saturates as pinch off occurs. Now when we keep VDS constant and we increase the VGS, increase in VGS decreases the drain current, and now the pinch off is observed, it occurs for the lower values of the drain current. In this experiment, we have seen how the drain current is dependent on VDS and VGS. I hope you have understood the working of JFET. Thank you.